This is lesson 7 of our STAAR review, identifying proportional and non-proportional functions. Okay, just a review on some vocabulary that we went over in the last lesson is a proportional relationship is two quantities vary directly with each other. Okay, you can represent proportional relationships in several ways. An equation in the form of y equals kx, where k is the constant rate of proportionality or unit rate. A graph of a straight line that passes through the origin, very important that it's straight and it passes through the origin to be proportional. A set or table of ordered pairs that shows equivalent ratios. Remember, equivalent ratios could be 2/10, which also equals 1/5, or it could go up to 3/15. All those are equivalent ratios. A verbal description that describes two quantities that vary directly with each other. Nothing's added to it. If something is added to it, a fine is added to it, a delivery fee, or whatever is added to it, it is not proportional. Okay, in a relationship cannot be represented by any of these ways, then it is a non-proportional relationship. Remember, a function is a specific type of relationship. All proportional relationships can be referred to as a proportional function. Okay, let's look at the example here. You have 4/100. What would be the unit rate of this? If we did the change of y over the change in x, where this is my x, this is my y, we would do 100 divided by 4. And you should get 25. We had 50/2. You're going to get 25. So those can be reduced to have the same ratio. So they are proportional. Okay, there's more notes that you can look through if you'd like. The basic thing to remember is that it's going to be your y over your x, and everything has to come out to the same ratio. So let's look at number 1. Brenda recorded the amount of time it took to cook potatoes in the microwave. Okay, so this is your P for potatoes and this is your T for time. This is your X, this is your Y. Which equation best represents the situation? First, just look at the table. See if there is a relationship. How did 2 get to 10 or 10 get to 2? If 2 potatoes were in the microwave, okay, we have to put them there for 10 minutes. So we're actually wanting the unit rate, and we can find the change of y over the change in x. So if we did that, that would be 10 divided by 2, which is 5. So we know there's a relationship of the number 5. 2 times 5 to get 10, or, as we did here, 10 divided by 2 to get 5. So let's look at our answers. Another way to test and prove your answers right or wrong is to plug in your x to see if you get your y. And if you do, it's great. They already told you which is your P and which is your T. So we just need to plug in our T and see if we get our P. So if I want to plug in my T, which is 10, 10 plus 8, did that equal 2? No, it did not. So just simply plugging in our numbers is going to help you prove which is your answer. So B, it has a relationship of 5, but let's see if it's the right relationship. If I have t, which is 10, and I multiply 5 times 10, am I going to get 3, which is what it's saying I would get? No, I do not. So that one is not the correct answer. C, if I substitute my t, which is 10, divided by 5, am I going to get my p, which is 2? Yes. So simply by plugging in my t into the formula to see if I get the p, we have found our answer. If I did t squared, that would be 10 squared. I'm not going to get 2. Number 2. Which of the following equations represent a proportional function? Okay, remember in the notes we just went over y equals kx, which is similar to our slope equation. So y equals 10, does that fit into our formula? No, there's no x there. Y equals 10x. So that could be y equals kx. It looks very similar, so let's do a little check mark by it. Y equals 10 plus x. No, we can't add. Y equals x squared. No, we cannot square it. So your answer is B. Number 3. Which statement must be true of the graph of a proportional function? Proportional function. We want to see which one is proportional. It has to pass through 0. Yes, all proportional relationships will pass through 0. It passes through 0, 1. No. It passes through 1, 1. No. It passes through 2, 4. No. So your answer has to be A. Number 4. Which graph shows a non-proportional function? Okay, we're looking for non-proportional function. If we remember the rules of proportional, it has to pass through the origin. So all we need to do is go, that's proportional, it's a straight line, and it goes through 0. B, it's a straight line, and it goes through 0. It's proportional. C, it's a straight line, but it's going to start at 2. D, it's a straight line, and it starts out through 0. So the only one that is non-proportional is C, because it started at 2. So this could be like a $2 delivery fee, a $2 admission into the park or something. It's going to be added on to your formula. So that is non-proportional. Number 5. The time that a phone requires to download a song depends on the size of the song. The table shows various download times for some songs. We have 1.5 megabytes equals 60 seconds. 2 megabytes would equal 80 seconds. 2.5 megabytes equal 100 seconds. So to see if there is a relationship, and I see one, that this is going up by 20 and this one's going up by 0.5. But let's go ahead and read our answers. Which statement is best describes the situation? The equation y equals 20x describes this non-proportional relationship. If this is my formula and it says it's non-proportional, that alone makes it false. Because remember, if nothing's added to it, it is proportional. If I put 0 here, that means y would be 0. And other than that, it's going to be going up by 20s. But it says non-proportional. With this equation is proportional, so it cannot be A. B, the equation y equals 40x describes this proportional relationship. Well, the equation itself is proportional, so that checks out. Now, like I just said a while ago, if we put your x's in to see if we get a y. So if I put 60 in, oh, no, here's your x. So if I do 40 times 1.5, do I get my 60? If I have 2 times 1.5, do I get my 80? Okay, and if you do, then this one is correct. C, the equation y equals 40x describes this non-proportional relationship. The equation by itself tells you it is proportional. There is nothing added to it. So it cannot be C. D, the equation y equals 60x describes this proportional relationship. The equation is proportional. So just put in your x, multiply it by 60, and see if you get your y. So if I do 60 times 1.5, will I get 60? Well, I can tell you no, because 1 times 60 is going to give you 60. 1.5 is not going to get you 60. So your only answer could be B. Number 6. Emma drew the graph of a function below. Which statement is true? Okay, we're looking for something that is true. This function is proportional. Look at the graph and see if you think it is proportional. We just stated on the other page that if it's proportional, it has to go through 0, 0. And it did not go through 0, 0. And we're looking for a true statement. So the function is proportional is false. That's not your answer, because we're looking for something that's true. The function has a form of y equals kx. Excuse me. We know that's not true because we started at 1. So that would have to be a plus 1 to be your y-intercept. So it cannot be B. C, the function passes through 0, 0. That one is not correct, so it's false. The function is non-proportional. Because it starts at 1, it is not proportional. So that one is true. This is non-proportional. Number 7. Which table shows a non-proportional relationship? I'm looking for non-proportional. Proportional relationships have ratios that equal the same. So if we made ratios, your change of y over your change in x, they should all be the same if it's proportional. So let's do that real quick. 4 divided by 4 is 1. 6 divided by 6 is 1. 8 divided by 8 is 1. 10 divided by 10 is 1. So this one is proportional. Okay, so it cannot be your answer. We're looking at for something that is non-proportional. B, 4 divided by 1 is 4. 5 divided by 2 is 2.5. So that tells me that these two ratios are not equivalent, so therefore it's not proportional. So your answer is probably going to be B. 15 divided by 10 is 1.5. 30 divided by 20 is 1.5. 42 divided by 48, 1.5. 51 divided by 34 is 1.5. This one is all proportional because the equivalents are the same. The ratios are equivalent. D, 11 divided by 1 is 11. 33 divided by 3 is 11. 44 divided by 4 is 11. 55 divided by 5 is 11. So the only one there that is non-proportional would be B. Number 8. Which point is not on the graph of the proportional functions that contains all the other points? Okay, so we know that it's going to be a proportional relationship, and one of these coordinates will not fit on that graph. To do that, again, we're finding the change of y over the change in x. This is your x, y. So we're going to do 14 divided by 4 equals. Then you need to do 31 divided by 5 divided by 9 equals. 18 divided by 8 equals. 42 divided by 12 equals. And when you do this on the calculator yourself, show your work, you're going to find that one is not equivalent to the others. One will not be equivalent to the others. So just real quickly, show your work. 14 divided by 4 is 31.5 divided by 9 is 18 divided by 8 is 42 divided by 12 is. The one that is not the same ratio as all the others will be your answer that is not on the graph. Number 9. Which situation best represents a non-proportional relationship? So again, we're looking for something that is non-proportional. Non-proportional means it does not go through the origin, and it usually has something added to it. So a farm stand, at a farm stand, each pound of cherries costs $3.75. Your keyword is each. So we could write that as y equals 3.75x. Because x would represent your pound. Each pound weighs costs this much, so that would be your total. Is that non-proportional or proportional? B. John is 3 inches taller than his friend Pam. So this would be Pam plus 3 inches equals John's height. Is that one proportional? C. For every 5 minutes you bicycle, you burn 45 calories. And your keyword there is every. Keyword up here is taller than. D. The circumference of each circle is about 6 times the length of the radius. So it would be 6 times your radius. So out of those 4 questions, which one is non-proportional? Non-proportional. Number 10. Ha buys 3 notebooks for $3.75. What is the constant rate of proportionality in the function representing the situation? So we're looking for the constant rate of proportionality. Remember in our notes, we said it's your unit rate. What is the unit rate per notebook? Okay, y equals kx. So if I had 375 times 3, because this is my x, That's going to give you your y. But I want to find unit rate. How do I find the unit rate? Change of y over my change in x. So 375 divided by 3. That's also how we find unit rate. So take 3.75, divide by 3, use proper place value, and fill in your bubbles in the correct place value. Number 11. The graph below shows the relationship between the number of gallons of ethanol-based gasoline and the number of gallons in regular gasoline sold at a gas station. Again, which is not required. And on our notes on this lesson, we had certain steps that were required for it to be a proportional relationship or a proportional function. Which one is not required? The graph passes through 0, 0. Is that required to be a proportional function? Yes, it is. That's in the first page of our notes. Graph straight line that passes through the origin. Okay. If 10-1 is on the line, then so is 30 over 3. Remember, we also talked about on that front page is they had to be equivalent proportionals, ratios. So 10 over 1 has to equal 30 over 3. So are those equivalent? Yes, they are. The graph is a straight line. Okay, so again, you look at your notes. Okay, it goes to the origin. It shows equivalent ratios. It varies directly with each other. And it has to be a straight line. Okay, so that one also is a requirement for it to be a proportional relationship. The graph passes through 10-1. That's not a requirement that every single proportional relationship has to pass through 10-1. Yes, it does pass through 10-1, but it is not a requirement. So your answer is D. All right, that's all for lesson 7. We'll cover lesson 8 tomorrow.